What was our learning target for this page? What did we say at the beginning of page 11 was our learning target?
I can simplify radicals.
Okay, can we kind of do that so far?
Yes.
I feel like we should be able to. It is. So when you have an index of 2, and that means when there's no number in the index, you always try to find, here's my card, the biggest perfect square. And we made cards that say the biggest perfect square on them. So it says simplifying radicals is easy with an index of 2. I read that backwards because I'm Yoda. This says just find the biggest perfect square that divides into the, what is this number called?
40.
No. It is 40, but what's it called? It has a specific name.
Oh.
Radican. Take a point. Now, you did do 40 yesterday, so can anybody tell me the biggest perfect square that divides into 40? It is 4. Good, take a point. So, remember, you're using the green column. You use the second, the fourth, and the sixth column. Don't use the counting numbers. The biggest perfect square that divides into 40 is 4. What's 40 divided by 4?
10.
Now, what does 4 get broken down into? 2 and 2. And since it's an index of 2, we need 2 of the same number. Do we have 2 of the same number? Alright, so what goes outside to play? And what stays inside to read Harry Potter? What stays inside? 10. Are we done? Because 10 can only be broken down into 2 and 5. And that's not 2 of the same number. Does everybody understand? Yes, no, maybe so?
Yes.
Okay. Can we easily flip back to our homework from the other night on the previous page, or is this going to be like a catastrophe? It's, yes, flipping papers is very confusing. Alright, so 24. Who can tell me the biggest perfect square that divides into 24? Bronson? 8 is not a perfect square. 4. Thank you, Manny. Take a point. 4 is the biggest perfect square, and you get 4 and 6. Now, what does 4 get broken down into? 2. Do we have 2 of the same number?
Yes.
So then we bring 2 outside, and what stays in to read Harry Potter? Dun, da, da, da. Did anybody get that right the other night? 3 people?
6. I almost did. 6 on the outside and 2 on the...
There's only 1 6, so it stays inside. What are you confused about?
Where are you getting the 4 from?
Okay, again, we find the biggest perfect square that divides into 24. Now, of these perfect squares, we know we can't use 25. Does 16 go into 24?
No.
Does 9 go into 24? Does 4 go into 24?
Yes.
And that's where we got the 6 from. Are you better now, pumpkin sauce? Okay. Let's look at 512. We're going to skip the cubes for the moment. Can anybody tell me the biggest perfect square that divides into 512? What now? 64. Does anybody agree or disagree? What is 512 divided by 64? Then we have one bigger because there's a perfect square in 8. Alright, everybody get your calculator since we're looking around like we don't know what's happening. Get your calculator. If you need to go get a calculator, go get a calculator. Has everybody got the calculator? 8 is not a perfect square. Alright, now, if you divide 512 by 64, you do get 8. But 8 has a perfect square that goes into it, which is 4. So you need a bigger one. Let's try 144. Please do 512 divided by 144 and tell me what you get.
3.5555.
So that does not work. Let's go bigger. What can we try next?
225.
Okay, let's try 225. So that doesn't work. Let's go a little smaller. What could we do?
96.
All right, please do 512 divided by 196.
169.
Does 196 not work?
Nope.
All right, let's try maybe 256. 256. That works? All right. So we're going to do 256 and 2. Does everybody see how we did that? We picked perfect squares and we divided until we got a whole number. Now, what does 256 get broken down into? 16 and 16. Do we have two 16s? All right, what number goes outside to play? And what number stays inside to read Harry Potter? Bum, 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 bum. Did anybody get that right the other night? Give your team a point. Good job, Henry.
Wait, you did it.
Did you get the same answer?
I mean, yes, you know.
Okay, then. Look at us go.
I need to make a new square root. I don't know.
Okay, great talk. Now, let's flip this back over. We will make another one in a minute, okay? When it's a cube root, you need how many of the same number? 3. Take a point.
It's over.
Yes.
There's no index, it's automatically right?
Yes. Isn't that what we wrote down in our notes?
Yeah.
Look at you go. When it's a cube root, that means that there's a 3 right here. You need 3 of the same number. So let's break down 25. 75.
You said it's supposed to be outside.
Oh my baby Jesus, can you just let me do this?
Oh, that'd be 25. I gotta ask you, remember how you said it wasn't supposed to be inside that?
This is the index.
Oh.
It is supposed to be in the mullet. That's a great question. So the other day we talked about how when you take a number to the outside, like here we brought 2, we don't put it in the mullet. That's because 2 is a coefficient. If there's a number already in the mullet, that's the index. Leave it there. Leave it there. Now, what number do we know goes into 75?
25.
Okay, 25 times what?
33.
Are you sure?
Yes.
No.
Do 75 divided by 25. Tell me what you get.
You get 3.
Yeah, 3.
Okay, I'm just making sure. All right, now, again, we need 3 of the same number. So can we break 25 down into anything?
Yes.
Into what?
5.
Now, those are prime numbers now. Can we break this down anymore? Do we have 3 of the same number? No. So our answer stays the cubed root of 75. Isn't it magic? All right, let's look at the second problem. I'm ignoring you for a reason. Who can think of a number that divides into 40? 4. Okay, 4 times what? All right, now remember, we need 3 of the same number. So what can we break 4 down into?
2.
Yes.
So, does it matter what side they're on?
No. All right, now, do we have 3 of the same number yet? But can we break 10 down into what?
5.
5 and 2. Now, do we have 3 of the same number? 1, 2, 3. So what goes outside to play?
2.
What stays inside to read Harry Potter?
40.
No. What number's left over? 5 is left over. Now, the 3 stays in the index. The 3 stays in the index. This says 2 cubed root 5 is our answer. Does everybody understand? Can I please stop talking to you like you're 4? Can we progress to like maybe 6 so I can talk to you like you're 6?
6.5.
Oh, 5.
All right, let's break 16 down. What number do we know without a doubt goes into 16? 4. All right, so you get 4 times what?
4.
Now, how many of the same number do we need now?
3.
Why? Because the index is 3. Awesome. What can I break 4 down into?
2.
What can I break 4 down into over here?
2.
Do we have 3 of the same number? Uno, dos, tres. So what goes outside to play?
2.
What stays inside the house?
2.
The other 2. And where does the 3 go?
On the index.
In the mullet, on the index. And you're done.
Yeah.
It was. How do we feel?
4 2s.
Right. We did. But we only take the 3 and bring it outside. What? That answered your question? Did you say that answered your question? Oh, okay. Awesome. All right, let's look back at our homework. We've had to find the cubed root of 1,000. Can anybody, that means we need 3. CJ, can you tell me what number goes into 1,000?
10 times 10 times 10.
So we have 10 times 100, and that gets broken down into 10 and 10. And so what's the answer? Fantastic, CJ. Take a point for your team. Does everybody see how we got that answer? 1, 2, 3. All right, what about 162? And remember we changed it to a positive. What's the biggest number that goes into 162? Does 3 go into 162?
Also, like
81.
81 times what?
like 81 squared.
81.
9 squared, which would be like 81.
Yes. Yes.
I can't English today.
I know. Breathe. It's okay. Okay. All right, so we got 81 and 2, but what can 81 be broken down into? All right. How many of the same number do we need? Do we have 3 of the same number yet? What can we break this 9 down into?
3.
And what can we break this 9 down into? Now, how many 3s do we have?
4.
We have 4, but we only need how many to go outside? So we have this 3 that goes outside. Now, what's left that stays inside to read Harry Potter? 2 and 3. And what are we going to do with those?
You go put 2 inside and 3 on the.
You combine them. Do you add them or multiply? You multiply them because we're dividing. Awesome. So multiply these together and 6 stays inside. So any factors you have left over, multiply them because this is called a factor tree. Dun, 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 dun. Ready? All right. Let's look at page 11E. What tells you how many of the same number you need? What part of our problem?
The index.
The index. Yes, take a point if you said index. All right, so it tells you how many of the same number you need in your factor tree. That's what those tree-like things are called that we make. So how many do you need here?
5.
You need 5 of what? The what? The same number. Good. Take a point. Can anybody think of a number that goes into 90?
Yes. 9.
9 and 10?
Yeah.
Okay. So let's see if we can get 5 of the same number. What does 9 get broken down into? And what does 10 get broken down into? Are we ever going to get 5 of the same number for 90?
No.
So that you leave it. If you can't get 5, leave it.
18 times 5 is 9.
But would you get 5 of the same number?
5, 18.
No.
No.
That's 18 times 5. If you had 5 18s, that would be 18 to the 5th power. But I like where you were going with that. And it's easy to confuse that because you did 18 times 5 and you're like, well, I got a 5. That's what it is right there in the index. But it's because you need the same thing over and over. And 18 times 18 times 18 times 18 times 18 would be giant. Awesome. All right. 5 of this. Oh, yes. Thank you, Bronson. 5 of the same number, leave it. If you can't get 5 of the same number, leave it. Oh, I wrote the wrong there because I was trying to do too much. Change this. What if there? T-H-E-R-E. Oh my gosh, that's going to drive me insane.
How?
T-H-E-R-E. I do know English. It's not possessive. You did. Alright, but what if there is a coefficient? Oh, that irks my soul. Nothing, Bronson. Alright, so you break it down like normal. So let's ignore the 4 up front. And tell me what we would break 12 down into. 3 and 4, because 4 is the biggest perfect square. Alright, and what's 4 broken down into? So what goes outside?
2.
Alright, so we have 2. And what stays inside the house? 3. So you brought 2 to the outside. You then have to multiply the coefficient by the number that goes on the outside. So what's 2 times 4?
8.
And you get 8 root 3. Dun, 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 dun. Does everybody understand? Are you sure?
I don't know, this test is driving.
I'll fix it later. Thank you for letting me know. Any questions so far? Are you alive? Why do we look dead? Alright, let's go to the next page then. We're going to add some variables in there. And our learning target is going to say, I can simplify radicals with variables. Can you thump him, please? Thank you. Look alive, baby cakes. Alright. So, you can have variables under the radical. I'm sorry, Troy. I'm sorry. Okay, so you can do it 2 ways. It's actually very simple. If it doesn't have a number right here, what's the index?
2.
2. So what you do is you divide the index into the exponent. So how many times does 2 go into 9?
It doesn't go into
It does. It can divide into it. You'll just have leftovers. So how many times can 2 go into 9? 4 times. Stop it. So you would have x to the 4th. And then how many would you have left over? You would have 1 left over, and that stays under the radical. Does everybody understand? So you divide the index into the exponent. 2 goes into 9 4 times. Anything left stays inside to what? What have we said over and over?
Water.
Thank you. I expect you to say it. And we're going to write it.
What about watch a movie? Or watch the movie?
Because we're going to read, because we're intelligent people. Now, you can do it that way, or you can break it down into 9 x's. So let's write 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what's our index? So we're going to group them into 2. So we have 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2. So that's where we got x to the 4th from. And then how many do we have left over?
1.
And that's what stays inside. Isn't it awesome?
Yeah.
I will only say nice things, and I will not say everything I think. I will only say nice things and not say everything I think. All right. Does anybody have any questions? What's your question? Okay. So then what if the index isn't 2? So what you would do is you would divide 5 into 7. So how many times does 5 go into 7?
1.
1 time, right? So we would have x, and then how many x's would be left over?
3.
2.
So I'm at 2.
So x squared would be left over, and that 5 goes right there. If you don't believe me, draw 7 x's. 1, 2, 3, 4, 5, 6, 7. And we need to group them into how many x's? No, what's our index? 5 this time. So you're going to group them. How many groups of 5 do we have?
1.
And then how many are left over?
2.
Dun 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 dun. Troy, what you doing, baby? You just saying numbers.
Oh, yes.
So you can do the same thing. Divide the index into the exponent, or break the variable down, then group. You decide which one you want to do, and try this next one without me.
I was thinking you can do it by 2.
Well, what's the index?
It says group by 2 right there. I guess it's just
That's when the index is 2.
Yeah. Okay.
What's your index here? Are you done with the second one? Okay. How many times does 3 go into 10? 3 times. So b cubed goes out front. And how many stay inside to read Harry Potter? 1. Did you put the 3 in the index?
Yes.
Now, if you don't believe me, draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
That's a good answer.
Yeah.
To draw it out? Yeah. And then how many are we going to put in each group? 3. So 1, 2, 3. And then 1 left over. Now, what's different about this one right here? There's 2 variables, but do you still do it the same way? You do. So 7 goes into 9 how many times? 1. Okay. 7 goes into 15 with how many left over? Let's make a little note here. With 2 left over. Yep. All right. 7 goes into 15 how many times? 2 times. With how many left over? 1. So then left inside will be a squared b. Now, if you can't do it that way, what could you do? Draw out 9 a's. 3, 4, 5, 6, 7, 8, 9. And then how many b's would you draw out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And how many do I need in my group? 7. All right, so 1, 2, 3, 4, 5, 6, 7. And there's 2 left over. We have 2 left over. All right. 1, 2, 3, 4, 5, 6, 7. Sir?
I said we believe you.
Oh, no. We're doing it. 1, 2, 3, 4, 5, 6, 7. All right. I have 2 boxes on my B's, right? And that's why I put B squared and 1 left over. Dun, 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 dun. Who remembers what the top bar of a radical is called? A vinculum. Take a point. Now, for homework tonight, you have a choice. You can do a maze where you break it down by cubed roots, like this, where you need 3. You could do a maze where you break it down with the square root, or you could do a maze where you break the variables down. Does everybody understand? So you get to pick.